Discrete time Fourier transform, DTFT. Today we will discuss about some questions on DTFT. Example 1. Find the DTFT for the sequence of xn equals to un. Un is the unit step. Functions. Solutions. We have to use the formula x exponential j omega equals to summations from n equals to 0 until infinity xn exponential minus j omega n. By using this formula, we will substitute the un into xn. Then, we know that un is equals to 1. So we will have summation n equals to 0 until infinity, 1 multiply exponential minus j omega n. By referring the geometry series, we know that summation from n equals to 0 until infinity, x power of n is which is similar with this function, exponential minus j omega n, power of j omega n. So we can, using this formula to get equals to 1 divided by 1 minus x. So we, using this formula, substitute the exponential. So we have 1 divided by 1 minus exponential minus j omega. Okay. Clear? Now we go to example 2. Example 2. Find the DTFT sequence of the xn when alpha n un. Okay. Solutions. Same, we have to use the x bracket exponential j omega equals to summation from n until 0, from 0 until infinity, xn exponential minus j omega n, using this formula. After that, we substitute the xn with alpha n un. So we substitute inside here. After that, we know that un is equals to 1. un is equals to 1. So we will have alpha n 1 here, exponential minus j omega n. Okay, so we can see here, alpha n have the power of n, exponential also have the power of n, so we bring out the power of n. So when we see these forms, is also similar with this geometry series formula. Okay, so we are using xn will be equal to 1 divided by 1 minus x. So we are putting this one in here is our x. So we will have 1 divided by 1 minus alpha exponential minus j omega. Okay, done. Now we go to example 3. Okay. Example 3. Find the DTFT for the following finite signal. Now you will have a signal x n equal to a for 0 n until 3. Okay, when the signal is 0, otherwise, which means we have a signal like this. This one is our x-axis, y-axis, we have xn. And our x-axis, we have n. Now our peak is a when we have the signal from 0 until 3. So we will have our signal here. Is the first signal A, second signal, okay, 1, n equals to 2, n equals to 3. So 0, 1, 2, 3. Others, 0. So others is 0. Others is 0. Okay. So this one maybe is 4, 4, 5. This one is minus 1. Okay. So the solution same also, we were using x bracket exponential j omega equals to summation from n equals to 0. Now this question we are having the n. This is our n. So until n number 3. So a, because this one we have the a, exponential minus j omega n. Okay, now we will sum up from n equals to 0, n equals to 1, n equals to 2, n equals to 3 for this signal. So for the n equals to 0, a exponential minus j omega, substitute n with 0, plus with a exponential minus j omega power of n equals to 1, so this signal. Okay, then we have a exponential minus j omega, n equals to 2, we have this signal, and a exponential minus j omega, n equals to 3. Okay, we sum up these 4 signals. Now, we sum up already when we know that exponential 0 is equals to 1. So we have a plus with a exponential minus j omega plus with a exponential minus j omega 2 and plus with a exponential minus j omega 3. Okay, we can see here we have a in each summations of the signals. So we can factorize the a out and bracket a factor out, bracket 1 plus exponential minus j omega plus with e minus j omega 2 plus with e minus j omega 3. Okay, done for question example 3. Now, we go to example number 4. So for example number 4, find the corresponding magnitude and phase for the signal x exponential j omega equals to 1 divided by 1 minus alpha exponential minus j omega. Okay, the solution is now we want to have this signal already in frequency signals. We are taking these frequency signals, transfer functions, and find the magnitude and phase. So, what is the magnitude? So, first, we will have exponential minus j omega. We know that exponentials using the Euler formula, we know that it can change to cos omega plus with sine minus j sine omega. Okay. Then we multiply our alpha into the cos and sine. So we will have 1 divided by 1 minus alpha cos omega plus with j alpha sine omega. Okay, this is the real part. This is the imaginary part. So, to calculate the magnitude, we know that we have modulus x exponential j omega. So, we will have 1 divided by such real square plus with imaginary square. So, 1 plus a 1 minus alpha cos omega square for the real part plus with our alpha sine j for sine omega. So, we do need to write the j. This one is our imaginary part square. Okay, to calculate our phase, we were using the formula. This formula equals to tangent, arctangent. We will take our imaginary parts divided by our real parts. So imaginary is alpha sine omega divided by real part 1 minus alpha cos omega. So done for our phase and our magnitude. That's all. Thank you.